Hey everybody, Trey here, back with another severe weather forecast discussion for a new severe weather setup tomorrow, Tuesday, October 12th, right on the heels of yesterday's severe weather outbreak across Oklahoma. This threat area for tomorrow going to be a little bit farther west, a little bit farther north than yesterday's event. There's a pretty big enhanced risk area here on the day 2 outlook from the SPC, stretching pretty much from the Kansas-Nebraska border down through the far eastern Texas panhandle into southwest Oklahoma, surrounded by a slight risk area that does encompass the Oklahoma City metro area. So once again, just a couple days after a big severe weather event, Oklahoma City back under the gun here for tomorrow. Threat not going to be as great for significant severe weather for Oklahoma City, but there is a threat for all severe hazards. So once again, Oklahoma City going to have to pay attention tomorrow to the weather. There is a tornado threat with this system, kind of spanning that enhanced risk area down toward the Oklahoma City metro area, as well as a damaging wind and large hail threat. So let's go ahead and get started here. And we'll take a look at the water vapor satellite imagery here. And if there was ever a website for weather porn, this would be on the front page. This is just a beautiful satellite image right here. Here's our system from yesterday that rolled across Oklahoma. Just a beautiful comma head now as it kind of matures and occludes here off to the northeast. That will be accompanied by a tornado threat here across Illinois today, but we'll focus now on our system that you can see here diving out of the Pacific Northwest. Big kind of trough, and with the difference I think between the troughs from yesterday to Tuesday will be the size. The trough yesterday was kind of more of a compact trough, quite small in size, but very potent. This one going to be much larger in size, so as a result, we're going to have a much larger threat area for severe storms. So this trough will continue to dig down toward the southeast into the desert southwest and eventually the southern plains by tomorrow. We'll take on kind of a negative tilt as it does so. And the one thing you have to worry about when you have back-to-back systems like this within just a couple day span is moisture going to be scoured out into the Gulf. Our dew point is going to drop significantly due to a cold frontal passage here at the surface. And as we look at our surface map here today, we do see that we have had a significant reduction in surface moisture here across the southern plains. All of Oklahoma pretty much, at least the western half of Oklahoma, has dipped down into the low to mid 40s for dew points, and even into North Texas here, Dallas-Fort Worth area in the very low 50s. And we'll take a look here though, go farther south here, and we do see that we have some sort of moisture, some sort of deep moisture down here, at least surface moisture down here in the South Texas region, Brownsville, Corpus Christi area. Mid to upper 60s into the 70s dew points down here. That is what's going to have to come north for tomorrow to help us get that severe weather threat going. But it's going to take some work as that is really confined to South Texas, and we have relatively dry air up to the north of basically the San Antonio area here, up toward Oklahoma and Kansas. But that should happen. We've got this potent trough out here. Once that gets closer to the Rockies and that flow starts to traverse those mountains, we should get lee cyclogenesis in a big way here across the far western plains. And so moisture return shouldn't be an issue as far as the quantity of moisture. It's the timing of the moisture that we're going to have to worry about. We'll take a look at what the models are showing as far as when those 60s plus dew points are going to return here. And one thing to note here, we'll take a look at some soundings from this morning. If you recall, for yesterday's severe weather event, we were seeing pretty dry air aloft and a fairly shallow moist layer at the surface. That's changed a little bit here. This is the Corpus Christi sounding from this morning, and you can see a very, very deep moist layer here down below about 750 millibars. So a very much deeper moist layer in the low levels here, and that's going to be much more favorable for our severe weather event for tomorrow. If that can get transported northward. We do still have some drier air and steep-ish lapse rates here aloft. And if we go to the Brownsville sounding, much more stout cap here observed, and a little bit shallower of a moist layer, but still better than what we were seeing for yesterday's event the day before, which would have been Saturday. So we're definitely seeing a little bit better of a profile here as far as moisture goes. Not quite as dry air aloft here, so that should be a favorable component for a severe weather threat. But again, it's going to be that timing of the moisture return that's going to be interesting to watch out. We'll take a look at if we have any EML out here, and this is the Albuquerque sounding. There are some steepish lapse rates, but they're well aloft. Not so much of an elevated mixed layer here. If we look at Amarillo, there is some layers of steep lapse rates here, especially from about 700 to 850 millibars. So that should translate west with the trough. So there should be a little bit of capping in place throughout the day tomorrow. But again, it's all going to be about timing. When is the forcing going to arrive, and when is that moisture return going to arrive? So let's take a look at the models here. We'll start off with the 12Z NAM. So this is the forecast here. This is the initialization, so we'll see there's our trough from yesterday moving off to the northeast, and that'll move out of the way and make room for this trough with lots of flow here on the backside, which means that this trough is amplifying and strengthening as it digs down into the desert southwest. And we'll look quickly at the 500 millibar chart here. We can see it's initialized pretty well. This was the analyzed 500 millibar chart this morning. Initialized pretty well here. You can see that kind of open wave here, pretty potent flow on the backside, 50 plus knots. We don't have any observations out here to corroborate the winds here, but would assume that this is pretty close to reality here. So we'll go forward in time here throughout the day today. That digs off and actually closes off over the Great Basin here. Lots of flow on the backside, rounding the base of that trough, and it's going to take on an increasingly kind of neutral to negative tilt here over the coming day or so. And you can see 0Z tomorrow, which would be 7 p.m. Tuesday evening. Close low centered over Colorado, Wyoming. Lots of flow around the base of that trough. Quite meridional flow up here into Nebraska and Kansas, but it's a very strong speed max here that is rotating around the base of that trough. And so it looks like forcing is going to arrive. We start to see the first signs of that Tuesday afternoon when we get kind of these short waves to rotate around. We'll actually look at 700 millibars just for to see if we can better see any short waves that are better defined here. And there is some semblance maybe here of one up here into Nebraska. Could be some elevated convection up there during the day. And it's tough to say. There could be these little subtle short waves here. You see these little kinks in the flow may help initiate storms. And there's kind of one right there around 0Z moving into southwest Kansas to northwest Kansas into the Oklahoma Panhandle, North Texas Panhandle area. That will likely be our first sign of convective initiation there, right around 0Z or just after there in the target area. So it's going to be kind of a later event. We'll go down to 850 millibars here to see when we get that. And you can see pretty much throughout the day today, we're going to start to see that cyclonic sort of curvature here at 850 millibars start to take shape as that trough continues to dig down. We'll get that low-level jet here across the plains overnight tonight, and then we'll really see that cyclonic flow and that low-level jet ramp up by late afternoon and early evening tomorrow. So we get cyclogenesis here in the northern Colorado, southeast Wyoming sort of region here. But big, broad, low-level jet there out of the southeast, fairly strong, 40 to 50 knots here by 0Z, and then it really ramps up after dark here into early Wednesday morning as that cyclone moves off to the east and northeast. But let's take a look at moisture here. That's going to be the main key here and what we're going to be watching throughout the day tomorrow for how sort of widespread this severe weather threat and what the timing for this severe weather threat is going to be. So you can see that surface low and that kind of Pacific front scoured the moisture off a little bit to the east, so we're pretty dry here over the central and southern plains. And really through much of the day today, we're really going to start to see that moisture kind of surge northward here late tonight into early tomorrow as we do get that low-level jet to start cranking tonight. We should start to see that moisture slowly come northward overnight tonight. And actually, let's go to the southern U.S. sector here, the southern plains sector, and see. Yep, we've got those 70s dew points confined to far south Texas here. And they're going to start to move northward here, start to advect northward late tonight into early tomorrow. And then we do get somewhat of a rapid moisture return here into the southern plains. Those 70s dew points, at least here on the NAM, reaching the Red River by 0Z tomorrow or 7 p.m. tomorrow. 60s dew points getting up to the the Kansas-Oklahoma border by 7 p.m. tomorrow, and then overnight we get that surge to continue, and then the front will move that off to the east. So that does look like areas to the north of this boundary of kind of 60s dew points are going to be dealing with at least high-based storms early on, if we can get storms to fire here. And this is right about when our forcing is going to get there, 0Z here. And so I think northwest Oklahoma, down into southwest Oklahoma, the far eastern Texas panhandle, those are the areas that are going to be first up for a severe weather threat Wednesday evening. So that simply is when the first areas that are going to see this more potent moisture return. And then overnight, once those 60s and mid-60s dew points reach into Kansas, then we'll see perhaps an increase in the intensity of the storms up here with northward extent. All right, let's go to the GFS here. This is our 12Z GFS here. So same kind of thing, big potent wave coming down here from the Pacific Northwest, closes off here, lots of flow around the backside. Then we'll go to 0Z tomorrow. You can see kind of the same thing as the NAM was showing. We'll go back here and go forward. And then we're going to zoom out here first, go to our continental US sector, and then go forward in time. We'll go to 0Z tomorrow, see kind of where these are placed and if there's any difference in placement. So there's our center of the closed low here, right over kind of northern Colorado there. Lots of flow around the base of that trough. And pretty much a similar scenario with the GFS. So not seeing a whole lot of difference there in the depiction with the overall trough here. Let's go down and see how the low-level jet progresses with the GFS. Remember, we started to see some reflection of cyclogenesis here, lead cyclogenesis here tonight. Start to get that low-level jet going, which is what we saw with the NAM. So not much difference there. And then Wednesday at 0Z, once again, a big, broad, low-level jet. We'll move this forward in time, and much of the same here on the NAM. So the GFS and the NAM are pretty much in sync. It's got kind of the center of that 850 millibar circulation there over northeast Colorado, and then just a big, broad area of 40 to 50 knot low-level jet there from the Dakotas all the way down into central Texas, which is what we're seeing with the NAM there. So let's look at moisture return now. Because again, this is the critical factor for tomorrow is going to be moisture return and how it's timed. So let's go to our south central U.S. sector here. We'll do the same for the NAM to compare the two. And then we'll look at the Euro here as well after we look at the GFS here. Let's go ahead and go back here. All right, so GFS, moisture return, once again depicts those 70s dew points down into far south Texas. And then we start to see overnight, as we get cyclogenesis here to the lee of the Rockies, that moisture starts to get pulled northward. And then actually, the GFS looks to be a little bit faster with moisture return. We can see by 21Z, it's got the 60s dew points all the way up to the Kansas-Oklahoma border there, up to the north of, say, the Woodward area. And if you recall with the NAM was a little bit slower with that moisture return. We'll look at 21Z Wednesday. You can see the 60s dew points have surged a little bit farther north into Kansas by that time. So that would bode well for a severe weather threat potentially starting. Areas farther north may be getting in on the severe weather threat earlier than what the NAM is showing. Here's the 0Z on the NAM. You can see by 0Z we get those up into Kansas. Surges a little bit farther north onto the GFS. Let me take a look at the central plains sector here so you can see the northward extent of that moisture return. And you can see by 0Z, it's all the way up into central Kansas, these upper 50s to low 60s dew points here, all the way up into even northwest Kansas here, just to the southeast of that surface low up in the far northeast Colorado. And then by 3Z, we continue to get that moisture surge off to the north and up into Nebraska. So this is interesting here. Little bit different depiction, at least, as well as a different depiction of kind of the shape of the dry line here. We have maybe more of a bulge here into southwest and western Oklahoma, and we always like to target dry line bulges. There's a little bit they're a little bit more favorable for maybe more tornadic activity, stronger supercells here. So we'll have to watch that, how the dry line plays out here. Maybe a little bit more forcing here along that dry line bulge later on, but it does look like the GFS is a little bit faster with moisture return here, so that will have to be something we keep in mind. Now let's look at the Euro. We'll just kind of breeze through this here. Much of the same as the other models, maybe just slightly to the west with the center of that trough by 0Z tomorrow, but really not a huge difference in the depiction of the overall trough here with the Euro. 850 millibar map here. Once again, broad low-level jet, broad strong low-level jet out of the southeast, increasing as you go overnight here across Kansas and Oklahoma. Much of the same there. But moisture return, let's take a look at that at the surface. And we'll zoom in here if we can to the south central US here. So moisture return. This is the Euro. 70s dew points down in South Texas. And let's see. So this is every 6 hours, so we're not going to get the resolution, at least temporally, that we saw with the other models. So this is by 12Z Tuesday, 18Z. This is 0Z Tuesday. Kind of much of the same as what we were seeing with the NAM, those 60s barely creeping over the Kansas-Oklahoma border there. And then maybe a little bit of evidence of that kind of dry line bulge there, which would be maybe a favorite area for supercells there. Far eastern Texas Panhandle, western Oklahoma, just east and northeast of that dry line bulge there. And then after dark, it surges northward. So interesting, a little bit of a difference between the NAM and Euro. It's what we saw with our Sunday severe weather event. There are just small differences here in the depiction of the troughs and especially the moisture return here. It looks like the GFS is a little bit faster with moisture return, which could imply a greater severe weather threat earlier on with convection than, say, the NAM and the Euro. So with, say, the NAM and Euro solution, the northern half of this enhanced risk area would not really see severe weather, at least potent severe weather, perhaps, until well after dark, toward midnight, when that moisture really surges up into that area, whereas areas farther south, southwest Oklahoma, northwest Oklahoma, far eastern Texas Panhandle, those areas would be in on the severe weather threat first. At least the more potent storms would fire here first, perhaps with a tornado threat, and which we'll take a look at in a second, and then we get in on the action up here, up into northwest Kansas. So let's take a look at some soundings here from kind of just some areas here in the risk area. Go to our Central Plains sector, and we'll look at both models here. GFS, Central US. All right, so this is it. We'll go to 0Z tomorrow. Actually, let's go to 21Z tomorrow, which would be pre-convective initiation, so late afternoon. We'll see how we're doing. Once again, you can see the NAM a little bit slower there. We'll start down here along the Red River near the Vernon, Texas area. And you can see we'll be capped here. We've got pretty decent inversion there that remains here late afternoon. Photographs already, though, are favorable for severe weather here. We'll have that low-level jet in place, upwards of 30 to 40 knots, already in place here by late afternoon, but looks like storms may still take a while. That forcing still a little bit too far to the west, but by 0Z, we'll probably start to see storm initiation here once that shortwave starts to move through and we get that cap to erode. Now, interesting here on the GFS at 21Z, we do have some curvature in the photograph there. Not quite as favorable as the NAM, but still favorable. But the interesting difference here is that we are uncapped by 21Z here with the GFS. We're not seeing any capping here remaining. Surface temperature is at 85 over 65 here. And that's probably the difference. The NAM only showing 76-degree surface temperatures here, so a little bit of a difference in the surface temperatures here. If we can get warmer temperatures, that cap will erode earlier on, and we'll be able to, any little shortwave that can come through may initiate storms during the afternoon hours. Although, we'll have to wait and see what happens with that. There could be elevated convection ongoing up into northwest Texas there early on during the afternoon, so that may temper the surface temperatures here, and that we may be seeing a solution closer to what the NAM is showing, a little bit cooler at the surface, which would keep that cap in place a little bit longer. Now let's move to 0Z when both the models were kind of showing that forcing starting to arrive into the southern plains here. So this is the NAM. We'll do a sounding here. This is at kind of the same spot, Red River, and you can see that low-level jet has really ramped up here by late afternoon. We've seen that low-level jet here at the 1 kilometer winds spike to about 40 knots here, from about 30 to 35 knots here. So big looping hodograph here in the low levels, upwards of 350 meters squared per second squared effective helicity. But we still do see that cap is in place. Temperatures only up to 77 here by 7 p.m. So that is something to watch tomorrow. If we can get a little bit warmer surface temperatures, we may be able to erode that cap a little bit faster and get storms to go a little bit earlier, and a better chance at surface-based storms early on. And let's go to the GFS here, kind of the same thing, right ahead of that dry line bulge here, which will be a little bit farther northwest so we get in the moisture there. And that's an interesting profile, showing that cap really building in quite quickly. Temperatures really cooling off here by early evening, by 7 p.m. Don't know if that's realistic, going from dropping about 12, 13 degrees here in just a couple of hours here. So not sure if that is a legitimate solution. That may be. Let's take one here from the better moisture a little bit farther east. Yeah, it's showing the same thing. That's odd to me. So not quite sure if the GFS solution here, as far as surface temperatures go and resultant instability there, is accurate. Now this is farther north, so up into northwest Oklahoma near the Woodward area, showing only a surface temperature of 70 there. So rapid cooling. So we got a cap in place, so storms may struggle to be surface-based there. But nonetheless, we do have a very large and looping hodograph, over 400 meters squared per second squared effective helicity there. And let's take a NAM sounding from the kind of the same spot there, up by Woodward. And we'll see here, much stouter cap here, a lot cooler temperatures up here, 64 degrees here at the surface. So that's really interesting. It's really cooling things off fairly quickly. Not quite sure why that is, to be honest with you. But let's go to 0Z. Let's go to 3Z, excuse me. So this would be 10 p.m. We'll take a sounding here, southwest Oklahoma once again on both models here. And compare. And there's the NAM, very much a large looping hodograph, still almost 500 meters squared per second squared effective helicity. And now we've effectively eroded that cap almost pretty much completely there in southwest Oklahoma. So by about 3Z, the NAM is showing that we will probably get initiation sometime after 0Z with that stout capping in place there. So by about 10 p.m. we should get storms to fire, at least in southwest Oklahoma. These would be surface-based and have a threat for tornadoes, potentially some strong, given this hodograph here. We'll look at the GFS now, same spot, a little bit different depiction. GFS now is capped, more capped at 3Z there. A little bit of contamination here, but not too bad. Still not quite as favorable a hodograph, but definitely more than adequate for severe storms there. And tornadoes, if we can get surface-based storms. That's the question. Will we get surface-based storms there or not? Given that cap on the GFS, it's weird how the models kind of flip-flop there. The NAM now showing it uncapped by 3Z. The GFS showing it more capped by 3Z. Which solution is more plausible? Well, if we have a strong low-level jet in place, and this is common in springtime events when you have a big sort of low-level jet, big low-level cyclone there in southeast Colorado, you oftentimes will get, and this happened on the Greensburg, Kansas EF5 night on May 4th, 2007, and several other days of note there in southwest Kansas, but oftentimes when you have just this strong low-level jet, you'll get continued moisture advection to the north, and you'll be able to overcome any capping inversion that may take place, or that may start to, which normally does start to build back in after dark. If you get that continued strong moisture advection, with that strong low-level jet, you may be able to overcome that inhibition and still get surface-based storms that produce strong tornadoes after dark there. So perhaps might lean a little bit toward the NAM solution given the strength of the low-level jet here. But we'll have to watch that if storms are surface-based here, because if they are, this could lead to big problems here. It's very strong, very large curvature here in the low levels for all of these photographs here. Let's look farther north up into Kansas here. We'll go kind of southwest Kansas, Dodge City area on both models here. Kind of the same thing, but much cooler, a little bit maybe more of an inversion up here in southwest Kansas. Equally large photographs here on the NAM. And same thing on the GFS, a little bit cooler, less dew points, less able to maybe break that cap up there. But nonetheless, a very large looping photograph there. So, and then my 6Z, which we have NAM showing those 70s dew points all the way up into western Oklahoma. And that could be a problem. This could be a huge problem here. This is at 6Z for west central Oklahoma, completely uncapped here. Large 0 to 3 kilometer cape of 172. That is well into the range for what we like to see for tornadoes. A lot of instability here, a lot of curvature in the photograph still, 450 effective helicity there. So if we can get discrete storms there into western Oklahoma, northwest Oklahoma after dark, they could have some pretty significant problems there as far as tornadoes go. Also, a large hail threat with discrete storms. And then, given the degree of forcing, I think we will get a squall line here eventually after dark. But let's take a look here at storm mode real quick. So we'll go back to, let's say 3Z. We've got a pretty much north to south oriented dry line here. And unlike what we saw with Sunday's severe weather event, where the initiating boundary was more northwest to southeast, we've got kind of a more north to south oriented boundary. So keep that in mind there. And then let's take a look at the 500 millibar flow here at 0Z. And we're seeing we've got a pretty good amount of perpendicularity here with the winds, at least with the 500 millibar flow, at least with southern extent. Up here into Kansas, the flow is a little bit more parallel to the initiating boundary. So therefore, we may have a little bit more, and this is at 0Z. So we'll go to 3Z, likely when storms will be ongoing. You can see a little bit more parallel to the initiating boundary is the flow, the mid and upper level flow up here into Kansas. With southern extent, though, much more perpendicular component to the wind vectors here at 500 millibars to that north-south oriented dry line. So I think there's a little bit better chance for discrete storms down here to the south across northwest Oklahoma, maybe far southwest Kansas, near kind of south of Greensburg area. And then kind of the Woodward area down into southwest Oklahoma. A little bit better of a chance here for discrete supercells down here. And we saw with the wind profiles, if we can get discrete supercells down here, they could pack a punch with tornadoes, perhaps some even strong. Again, going to have to wait on the degree and timing of the moisture return there, but wind profile definitely suggestive of strong tornadoes there on both the NAM and the GFS here for parts of northwest and southwest Oklahoma, perhaps the far eastern Texas panhandle. So, and then I think as that forcing really starts to move in, we'll probably get a squall line to form here as storms kind of congeal along that boundary overnight into Wednesday morning. So one last thing here, we'll take a quick look just for giggles here at the HRRR model. Of course, we shouldn't really be trusting the cams this far out. But we'll take a look just to see a rough depiction of what the HRRR is showing. This was the 12Z run, and you can see we may have some elevated storms out here early on in Oklahoma, parts of Texas. Those should remain sub-severe. Then we get some precipitation to fire as that forcing comes in across eastern Colorado into the far northwest Texas panhandle. And then storms become more numerous here, and we see, actually, interestingly, storms start to fire here well to the north of that moisture surge. This is only at 1Z, and we'll quickly take a look at what the HRRR is depicting for the moisture return. Again, not going to be trusting this too much at this point, but pretty much in line, kind of a middle ground between the NAM and GFS. NAM was closer to the Kansas-Oklahoma border, GFS a little bit farther into Kansas by 0Z, so kind of a middle ground here. And so it's interesting that the HER is firing storms farther north in the worst moisture here. Would expect those to kind of be more outflow dominant, perhaps congeal a little bit more quickly, given outflow consolidation with these storms up here. But if we go back to the forecast radar reflectivity, we'll notice that we don't quite get as much to fire here across this area: far northeast Texas Panhandle, eastern Oklahoma Panhandle, far southwest Kansas, northwest Oklahoma by 0Z. And then we perhaps get some semblance of discrete storm development here, maybe semi-discrete storms up into southwest Kansas, down into northwest Oklahoma by 3 to 4Z. And I think these would have, if this is close to reality, this would be at 5Z. So closing in on midnight here. If these are semi-discrete here, we saw a little bit better chance for them to be discrete down here. These would have a potentially strong tornado threat along with a large hail and damaging wind threat. This is the HER profile showing a little bit of that inversion remaining here, but it's not too bad. We'll look SIN values, surface-based SIN, negative 44. That is definitely can be overcome with a strong low-level jet and continued strong moisture advection. But notice this photograph is pretty ridiculous here, almost 600 meters square per second squared effective helicity. So if we can get discrete surface-based storms in that environment, I do think there will be the potential for strong tornadoes, significant hail. And then overnight, you see this, everything kind of congeals into a line. Oklahoma City metro area by the time it reaches you will be Wednesday morning. So everything will congeal into a squall line. By then, mostly a damaging wind threat here for the Oklahoma City metro area, Tulsa metro areas into Wednesday morning. So interesting setup here for sure for tomorrow. Again, enhanced risk is in play for far north Kansas down into southwest Oklahoma. As of now, just looking at things, looks like the best chance for the most potent, maybe more discrete supercells will be here across western Oklahoma, the far eastern Texas and Oklahoma panhandles into far southwest Kansas, where the upper level flow is a little bit more perpendicular to the initiating dry line boundary, and where the moisture surge is likely to reach is going to reach first here. So as far as timing goes, looks like it's going to be an after dark event. Looks like we may get storm initiation as early as maybe 0Z, maybe 23Z. I have to monitor the timing of that, the forcing, and that timing of that moisture surge. But looks like storms will fire around 7 to 8 p.m. here across the risk area. They'll move off to the east and northeast here, again, with a tornado threat. Wouldn't be surprised if the trends hold here to see them bump up the tornado probabilities for northwest Oklahoma. But again, a little bit too much uncertainty with the moisture return there to bump those up for the day 2 outlook today. So that is going to be what we're watching, is that the timing of that moisture return. If it can surge a little bit farther north a little bit faster, then we might see a severe threat farther north earlier on. Whereas I think these storms that form here up to the north earlier on, if that moisture surge stays south, will be a little bit less potent, maybe more outflow dominant with a damaging wind and hail threat. And the tornado threat will be confined here to areas where that stronger moisture is. So that's all I've got for now. Planning on perhaps doing another video tomorrow morning, outlining what may have changed with the models and going over the observations tomorrow morning. So if you live in these areas, if you live in the orange and yellow areas here, in particular, keep an eye on the weather tomorrow. Keep your weather radios handy. It's going to be another pretty potent severe weather event on tap. So that's all I have for now, and I appreciate you watching, and we will see you with the next video.